All right, in this problem, we're going to apply the remainder theorem to find a missing value. We're told that we have this cubic trinomial where x minus 2 is a factor of it. So if I was to factor it, this would have a product that would multiply out to be this thing. But we don't know this k value. This k value is some number, it's just a constant. And so our job is to find it. The way we do it is we work to understand what this means to say that x minus 2 is a factor of the function. And what it means is that if I did division with this function by the x minus 2, the remainder would be 0. A factor means remainder equals 0. So that means I can use the remainder theorem that says that if I put positive 2 into the function, I would spit out the remainder value. Well, the remainder value is 0. So all of this hinges on me knowing the remainder theorem. And that x minus 2, if it's a factor, it would actually be a 0, an x-intercept, so I can add 2 to both sides here and get x equals 2 as a result. So that means if I did synthetic division, or here I'm just going to short circuit it and use the remainder theorem to find f of 2, the remainder will be my result, and my remainder should be 0 if it is a factor, which it is. So I find f of 2 by plugging in 2 for each x value. So that's going to be 3 times 2 to the third minus 2 times 2, and then plus k. So the whole game is just figuring out that 0 is what you set this equation equal to, and once you do that, you just isolate for k. The rest of the work is fairly straightforward. It's all about identifying that f of 2 would be equal to 0 and then actually doing f of 2 and solving for k. So here we go and work this out. This would be 3 times 8 minus 4 plus k equals 0. And then we get 24 minus 4 plus k equals 0. So 0 equals 20 plus k. So k equals negative 20. If k is negative 20 up here, then if I could do division and x minus 2 would have no remainder. If I factored this now with the negative 20 right there, the x minus 2 would be one of the factors.